Good morning. Today we are going to be reviewing what we have covered so far on chapter 10, which deals with probability, permutations, combinations, and of course, the binomial theorem. So we're going to go through the front page, and then your homework will be to work what's on the back. And yes, I apologize. I only gave you guys this few problems for homework. So remember that you want to make sure that you understand each of them. So I'll go through each one of them. And hopefully that will help you guys, for those of you guys that were absent due to the KC or do not understand a specific problem. So let's go and start with problem number 1. It says, now all of you guys should have a highlighter and a red pen to be able to highlight the key concepts of each problem. It says, use the binomial theorem. So we need to be able to use the binomial theorem to write the binomial expansion. We have 2x minus 3 to the 5th power. Now in order to start, we're going to use our Pascal triangle. So let's go and build the Pascal triangle all the way to the left. We're going to have start with a 1. So see if you can do it by yourselves. 1, you got that one? Then 1 and 1. Now must continue with the 1 on the left. Remember, it has to be a triangle. In here, I'm going to go and add up those two numbers, and that'll give me a 2. End up always with a 1. You got to start with a 1. Remember, we're looking for the 5th row. I'm going to add up those two numbers. That gives me a 3. Add up those two numbers. That gives me a 3. And end with a 1. Start with a 1. Add up those two numbers. That will give me a 4. Add up those two numbers. That will be a 6. Add up those two numbers. And that will give me a 4. We end with a 1. Start with a 1. Those two numbers will give me a 5. Those two numbers will give me a 10. Those two numbers will give me a 10. And last will give me in 5. And let's not forget about the 1. This to the 5th power. So we're going to be using this row. 1, 5, 10, 10, 5, 1. So let's go and write them down. There'll be a 1, then a 5, then a 10, then a 10, then a 5, and last will be a 1. Now, letter A will be 2x, will be 2x, 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 and 2x. The exponents. Remember, we're going to start with the 5 all the way down to 1 all the way down to 0. Now the letter B, which will be a negative 3 in this case, negative 3, negative 3, negative 3, negative 3, negative 3, and negative 3. And don't forget to place a plus in between each one of them. And what did I forget? My exponents for the negative 3. Now the 5 went from 5 all the way down to 0. Letter B will be from 0 all the way up to 5. And now we just need to simplify each one of them. So let's go and simplify the first one. Must simplify all 3 of them. I have a 1. I need to simplify 2x to the 5th. That is 2x times 2x times 2x times 2x times 2x. So that will give you 32x to the 5th. Remember, you want to be able to write small. Now, negative 3 to the 0 power, anything to the 0 power is 1. Multiply all 3 numbers will give you 32x to the 5th plus Let's bring down the 5. We're going to simplify the next set, the next term. 2x to the fourth power will be 2x times 2x times 2x times 2x. That'll be 2, 4, 6, 8, 16. So it'll be 2, 4, 8, 16. That will give me 16x to the third power. And now, negative 3 to the first power will be negative 3. You're going to multiply all three numbers. 5 times 16 is 80 times negative 3. 80 times negative 3 will give me negative 240 x to the power of 3. Now I'm going to simplify the next term. So I will positive 10. 2x to the third power will be 2x times 2x times 2x, which will be 8x to the third power. And I still have my negative 3 to the second power, which is negative 3 times negative 3 is positive 9. I'm going to multiply all three numbers. 8 times 9 is 72, times 10 is 720x to the power of 3. Positive. Now let's continue to the next terms. I'll simplify this out. That's a 10, so positive 10. 2x to the second power will be 2x times 2x, which will be 4x to the second. And negative 3 to the third power will be negative 3 times negative 3 will be 9, times negative 3 will be negative 27. 4 times 27. 4 times 20 is 80. 4 times 7 is 28. That'll be negative 108. And multiply by 10, add 0, and we have x squared. So you basically just multiply all three numbers. You can multiply 10 times 4 is 40, times 27 will give you 1080. And remember, positive times negative will give you a negative. Let me simplify the next one, and then I'm running out of space, so I'm going to cheat a bit. I'm going to extend it. Let me multiply the next set. That gives me a positive 5. 2x to the first power will be 2x. And negative 3 to the fourth power will be negative 3 times negative 3 times negative 3 times negative 3. 99 is 81. So it gives me positive 81. Multiply this out, that gives me 162. Or let's see, that gives me 10 times 81 will give me positive 810x. Last, I'm going to simplify the last term. So it gives me positive 1. 2x to the 0. Remember, anything to the 0 power will give you 1. And negative 3 to the fifth power will be negative 3 times negative 3 times negative 3 times negative 3, which will be negative 243. Multiply all three numbers together, so it gives you negative 243. And that will be your answer. This will be your binomial expansion. If you expand, if you multiply this 5 times using the FOIL, you'll get exactly the same answer if you are careful enough. But this will be much easier. And yes, I made one little mistake. Did you guys catch my mistake? Somewhere in here. There you go. That should be a 4. Right? Now, one of the things that you want to make sure that you are careful is that whenever you set up your problem, the exponents should always add up to 5. So that gives you 5, 5, 3 plus 2 is 5, 5, 5, and 5. And that will always be true. Now let's go into problem number 2. On problem number 2, it says, you are assigned 7 reading assignments over the summer. In how many ways can you complete the reading assignments if you must read the story of Pi first? So that's one of the stories that you need to read. So let's go and highlight the key information. You are reading 7 assignments over the summer. How many ways can you complete the assignment if you must read the story of Pi first? Remember, we have different types of problems. We have the probability problems, we have the dashes, and we have the combination. In this case, we are kind of rearranging the way we are reading the assignments. So rearrangements, that means that we're going to have to do our dashes. 1, 2, 3, 4, 5, 6, 7. Now the story of pi has to go first, not last. It has to go first. And if it has to go first or if it has to go last, it really doesn't matter. Now, some of you guys have any problem that whenever you have a last, you start with 7, 6, 5, 4, 3, 2. No. It doesn't matter where it is. You're going to place it first. How many stories are left? 6. So it'll be 6 times 5 times 4 times 3 times 2 times 1. Right? You have 6 stories left. So if you place one here, then you have 5 left. If you place one here, you have a total of 4 left. Then 3, then 2, then 1. Then we're going to multiply those numbers. That gives me 30. Multiply. That's 12 times 2 is 24. And times 1. 3 times 24 will give you 72. And don't forget to add your 0. So there are 720 different ways that you can read all of the stories if you read the story of pi first. Problem number 2. Let's go and read the problem together. It says, Victor wants to create a 5-digit screen name without repetition. So we have a 5-digit screen name without repetition. How many screen names can he create in this way? So we're going to end up with 5. Once again, we are selecting 5 different digits. Now remember, on your quiz, a lot of you guys are just going 5, 4, 3, 2, 1. You are looking for digits. You have to understand what is a digit. Just like we covered before, the digits are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And sometimes it says non-zero digits. So you cannot use a 0. In this case, it doesn't. So we have also the digit 0. So how many digits are available for the first spot? Let's see, 10 of them. Now let's assume that you selected one of them. You selected 3 for that spot, for your screen name. How many are available for the next one? We already took one out, so it'll be 9, 8, 7, 6. Multiply that. That gives me 90. Well, let's multiply this out, gives me 72. Multiply this out, gives me 42. And let's not forget about those zeros. Now we're just going to multiply 72 multiplied by 42. Remember, on your test, you're not going to be able to use a calculator, so you should be able to do it by hand. And that gives you 28. Add them together, so it gives you 32, 0, and so your answer will be 3,024 different screen names if you want to be able to use 5 numbers, 5 digits. Let's continue to problem number 4. Remember, I'm going over the different type of problems that you guys will be seeing on this chapter, or that you have seen on this chapter. 5 teams are competing so we have 5 teams that are competing on the final round of the Olympics for a 4-person bobsled. In how many ways can 3 bobsled finish first, second, and third? So they're all in a race, and remember, the fact that it's a 4-person race, 4-person per bobsled does not matter. So we're just looking for the 5 teams. We're looking for first, second, and third. First, second, and third. It doesn't matter who finishes 4th or 5th. It really shouldn't matter who finishes 2nd and 3rd, but in this case they do ask you about it. So how many teams are available for the first spot? All 5 of them. One of them crosses the line. Shoo. Now how many of them are available for second spot? 4 of them are still behind. The second one crosses the line. Shoo. How many are available for the 3rd place? There's 3 still competing. And we don't care who finishes 4th or 5th. We multiply it out, so it gives me 12 times 5 will give me 60 different ways that those 5 teams can finish first, second, or third. Make sure you read the question carefully. Problem number 5. A factory is making a new sports shoe design that comes in 3 different styles. So you're looking for 3 different styles and 8 different colors. How many different combinations, so combinations should give you a little clue, are possible if you can only choose one design and only one color? So we are selecting. First, we need to be able to select the styles. How many styles are available? 3. And how many are we selecting? Only one design. And that's what I mean by it. They should say one style, one design. Sorry for that. Times and multiplication. How many colors are available? 8. And how many are you selecting? 1. Remember, 3 choose 1, you don't need to expand it. So it'll just be 3. 8 choose 1, you don't need to expand it. That'll be 8. So it'll be a total of 24 different designs. Now let's continue to problem number 6. Mike has 9 friends who are interested in joining his bowling league, but he only has 3 openings. How many different ways can he select 3 of them? Remember, you are looking for keywords. In this case, select, you are choosing, you are selecting, and you are selecting all 3 of them at a time. You're not selecting one and then another and then another. You're selecting all 3 of them at the same time. So in this case, it will be, how many are available? 9. How many are you selecting? It will be 3. So be expanded, 9 factorial, denominator. 9 minus 3 will be 6 factorial, and then 3 factorial. 9 times 8 times 7 times 6 factorial. That will cancel with the 6 factorial. Cancels. And then we have 3 factorial will be 3 times 2 times 1. Let's see. 2 times 1 will give you 2, and the 8 will give you a 4. 3 and 9 will give you a 3. So multiply 4 times 3 times 3. That gives me 12 times 7 will give you 84 different ways that you can select 3 out of those 9 friends that are interested to join your bowling league. Now let's continue to problem number 7. On problem number 7, it says a standard deck of 52 playing cards has 4 suits, 13 different cards in each suit. So in this case, they just give you the basic information. They tell you that there are 52 cards, 4 suits in the deck, and there's 13 different cards in each suit. All the information that you already know. Now this is the question. If the order in which the cards are dealt is not important, which usually isn't, how many different 3-card hands can you get that are all black? Now remember that you are only concentrating on the ones that you are looking for. The fact that you have 52 cards or that you have 4 suits or 13 does not matter. How many black ones do you have total? Anybody knows? We have a total of 26. And how many are you looking for in each hand? 3. So the fact that 52 doesn't matter. We don't care about the other 26 that are red. We're only looking for the black ones. In this case, we're going to expand this. So it'll be 26 factorial over 26 minus 3 will be 23 factorial multiplied by 3 factorial. So it'll be 26 times 25 times 24 times 23 factorial. Of course, you don't need to go all the way down. That will cancel with the 23 factorial. And 3 will be 3 times 2 times 1. Let's see, this 2, that will give me 6. Cancel with the 24 and gives me a 6. So let's multiply all 3 numbers together. I'm just going to do it on a little piece of paper on the side. And if you want to do that on your homework, that's fine. Just get a little notepad and just multiply 26 times 25. That is 30, carry 3, 10, that'll be 13. That's 12, carry 1, that's 4, that's 5. And 0, 5, 6. 650 and multiply by 6. 0, 30, carry 3, 36, 39. So it'll be a total of 3,900 ways that you can get three cards that are all black. Problem number 8, it says, Laura has moved to a new apartment. She has 3 math books, 7 English in her backpack. If Laura opens her backpack and selects 5 at random, what is the probability? Now remember, that's the word that you're looking for. Probability, that means that you're going to be having a fraction. Now the question is she selecting one and then another and then another and then another and then another, or is she selecting all of them at once? So it's a 1, 1, 1, 1, 1, 1, or all of them at once. In this case, she's selecting them all at once. So we have to use the choose. Probability that she has 5 English books will be first on the numerator. How many English books do you have total? 7. And how many do we need to select? 5. On the denominator is all of them. How many different ways can you select 5? Doesn't matter if they're math or English. So how many books total? That'll be 10. And how many are we selecting? 5. So we just simplify each one of them. So let's see. That'll be, on the first one, will be 7, choose 5. Will be 7 factorial over 7 minus 5 will be 2 factorial and 5 factorial. We just expand it. So it'll be 7 times 6 times 5 factorial. The 5 cancels with the factorial, and then we just have 2 times 1. That gives me 3, so that gives me a 21. Denominator, 10, choose 5. So it'll be 10 factorial, 10 minus 5 will be 5 factorial, and 5 factorial. So it'll be 10 times 9 times 8 times 7 times 6 times 5 factorial, which will cancel the 5 factorial. Then we have 5 times 4 times 3. Expand this. Or you guys can't see. Sorry for that. There we go. So in this case, we have 6 and 5 factorial, which cancels with the 5 factorial. And 4, 3, 2, 1. So now let's simplify. The 4 and the 2 gives me a 8, so that cancels. The 3 and the 6 gives me a 2. The 5 and the 2 gives me a 2. So therefore I have 2 times 2 is 4. 28 times 9. So 28 times 9, that'll be 72. Carry 7. 18, that'll be 25. So it'll be 252. 252. Just be careful. I'm going to give you guys scratch paper on the test so you guys can actually expand it all the way through. And you can do this on a separate piece of paper and just attach it to it. That's not a problem. Now, if you're not sure if you can reduce it, that's fine. I mean, you should be able, because the numbers 2, 5, and 2, they add up to 9. I know that it should be able to be divisible by 3. But for now, let's just leave it like this. It's not a problem. Ideally, you have a calculator, you can change to a decimal and then to a percentage. Problem number 9. On problem number 9, it says a bag contains 7 pencils and 3 ball pens. Ronald is taking one writing object from this bag, places it back in his pocket, and then selects another. So remember, in this one, you're selecting one and then another. What is the probability? Probability means that you're going to have a fraction, that it takes two pencils out. So we have the probability of a pencil and a pencil. What's the probability of getting the first pencil? Even though the first time you're only taking one, we have to think, how many pencils are available? 7. How many writing objects are total? 10. Times. What happens to the pencil? He places it in his pocket. So second one will be 6 out of 9. So we're going to reduce. We're going to divide it by 2. So it gives me a 3. Gives me a 5. I'm going to divide that 3 and the 5. Divide by 3 gives me 1 and gives me a 3. So that gives me 7 over 15. Remember, you want to be able to reduce before you multiply it up. On problem number 10, we need to be able to find an equivalent to 3x squared minus 27x divided by 3 minus x. First, we're going to start by factoring the numerator. So if you notice, I need to first take out the common factor. One number divides 3 and 27. I can factorize 3. And this is the problem that many of you guys are missing on the test. So let's be careful. What do I need to multiply 3 to get 3x squared will be x squared. And what do I need to multiply 3 to get negative 27 will be negative 9. On the denominator, if you notice, on the denominator is not written correctly. It should be the x should be first and then the 3. So it should be a negative x, then a positive 3. And now I can continue factoring the numerator. So I can factor the x squared minus 9. You guys will notice that this is the difference of two squares. X squared minus 9, they both are squares. So therefore, I still have my 3 outside. And the x squared minus 9, we're going to use the double parenthesis to factor. And there'll be factors of x squared will be x and x. Factors of 9 will be 3 and 3. 1 negative and 1 positive. On the denominator, nothing to factor out, but we cannot have a negative inside as a leading coefficient. So I'm going to factor a negative 1. So it'll be negative 1 times x will be negative x. And negative 1 times what will give me a positive 3 will be a negative 3. And now I can see what cancels. Let's see what cancels. We have the x minus 3 cancels. So therefore, nothing else factored. Now we have a 3 divided by negative 1 gives me a negative 3. And my x plus 3. So therefore, my answer is negative 3x plus 3, which is letter negative 3 at the first, so it'll be letter A. So just be careful, especially with the denominator, is the main mistake that you guys are making. On number 11, let's read the following problem. If the order in which the cards are dealt is not important, how many different 5-card hands, so we're going to be selecting 5 cards at a time, can you get that are all diamonds? Now, a lot of the times they're going to give you the description for the deck. We have 52 cards, 13 in each suit, 4 suits. But in this case, what cards are we playing with? We are only playing with the diamonds. So how many diamonds do we have? And we are selecting 5 cards. So how many diamonds do we have? 13. And how many are we selecting at a time? 5. I'm going to expand it, so it gives me 13 factorial over 13 minus 5 is 8 factorial and multiply by 5 factorial. Expanded 13, 12, 11, 10, 9, and the 8 factorial is going to cancel with the 8 factorial. That cancels. So the 8 factorial is gone. That was the 8 factorial. And on the denominator, we still have the 5, the 4, the 3, the 2, and the 1. So let's see. The 4 times 3 will give me a 12. And 2 times 5 will give me a 10. So I just 13 times 11 times 9. 11 times 9 is 99 times 13. That'll be 27, carry 2. 27 and 2 is 29. 9, 9. 7, 8, 12. So my answer will be 1,287 ways that you can get 5 cards that are all diamonds. Let's go continue to the back side. This is the last problem that we're going to be working on. And then the rest of it will be your homework. I know it's only 25 problems, but we've already have done half of it. On number 12, I have an equation. But if you notice, I have a fraction. Now, automatically, I know that the denominators cannot be 0. And since we have a variable, I know that the value of x cannot be equal to 0. So we do have a restriction or an exception. Whenever you have an equation, you want to get rid of the denominators. So we're going to multiply by the LCD. In this case, your LCD, I want to cancel this x, so I'm going to multiply by x. I want to cancel both of these x's, which is x times x. The first x will cancel with the x, and I need one more. So my LCD will be x and x. So I'll multiply each one by x times x, x times x, x times x. On the first one, nothing cancels. So I just have x times 1 gives me x squared. On the second one of the x's cancels. So now I have a negative 2x. And on the last one, both x's cancel. So I just have it equal to negative 3. Now, ideally, I want to see if I can factor this out. But by looking at the answers, I know that this cannot be factored. No leading coefficient and your b value is even. So therefore, I'm going to complete the square. I'm going to leave some space, and the negative 3 goes to the other side. Now, I need to complete the square. Do you remember what number goes in here? You take half of 2, which is negative 1, and negative 1 times negative 1 is positive 1. And you add 1 on both sides. Now, I'm going to factor the left-hand side. Double parenthesis, and that's going to be equal to negative 2. So factors of x squared are x and x. Factors of 1 are 1 and 1, and they both should be negative, because they need to add to a negative 2. They both are exactly the same, so I have x minus 1 squared is equal to negative 2. And no, that was not the bell for you guys yet. So let's continue with this problem. I'm going to take the square root on both sides. The square root and the square cancels. So I just have x minus 1 is equal to, what happens whenever I have a negative inside? It's going to be a I. And I cannot simplify the square root of 2, so it stays as square root of 2. But let me not forget my plus or minus. So my answer should have an I, so I can get rid of letter B and letter D. Then I'm just going to move my 1 to the right. It's a negative becomes a positive 1. Plus or minus I square root of 2. So my answer should be positive 1, which is letter C. So go and complete the rest of it for homework. And then we can go over the answers on Monday or Tuesday, the next time I see you. Have a great weekend, everybody. Miss you all. Bye.